So we're going to use these rectangles to model how to find the area, both as a sum and as a product. We're going to be using the distributive property. Go ahead and take a look at the back side of your worksheet, and we're going to look at numbers 1, 2, 3, and 4. So the first thing we're going to do is look at the area as a sum. So we're taking the left area of the left rectangle and we're adding it to the area of the right rectangle. And the formula for area is length times width. Okay, so area is equal to length times width. So if we take the 2 and we multiply it by the p, we have 2p. So now we have to add the area of the right rectangle to it. The height of the rectangle on the left, or the length of it, is 2. It is the same length as the area, as the rectangle on the right. So now we're going to do 7 times 2, which is 14. So the area as a sum is 2p plus 14. We have multiplied the 2 by the p and by the 14 and then added them together. So now we're going to go ahead and find the area as a product. So if you notice, the 2 is the same. The height is the same. So what you're going to do is you're going to multiply that 2 for the height times p plus 7, and that's the distributive property. 2 parentheses p plus 7 is the same value as 2p plus 14. They are equivalent expressions. One is written as the area of as a sum, and the other one is written as the area of as a product. Looking now at number 2, we have the area of the left rectangle, which would be 3 times 8, which is 24. And then it's got, again, that same length. So now we have 3 times t, which would be 3t. Writing it algebraically, your term with the variable comes first, so it would be 3t plus 24. That is the area written as a sum. Now to go ahead and write it as a product, we're going to do 3 is the same in both rectangles. So you factor So now you're going to try the right-hand side, numbers 1 through 4, these problems on your own. Go ahead and hit pause. When you are done, hit play again, and I'll go ahead and go through the problems. Make sure that you write each one as both a sum and a product. So whenever you look at this and we write it as a sum, we're going to find the area of the rectangle on the left. We're going to do length times width or base times height. Same thing. We're going to do 3 times h and we write that as 3h. Then you have to take the 3 and multiply it by the 7 and you get 3 times 7, which is 21. That is the area as a sum. To take this and write it as a product, the 3 is what's going to be the same, okay? Because if this is 3, this height is also 3, or length is 3. So you're going to factor out the 3, and you're left with h plus 7. So you have 3 times the sum of h plus 7. These are equivalent expressions. Looking at number 2, this one's a little bit trickier because we've shifted the shape. If this is b, then this is b, and then this line is b. Okay, so you have to do 6 times b, which would be 6b, and then you have to do 3 times b, which would be 3b. So writing those as a sum would be 6b plus 3b, and whenever you simplify that, that becomes 9b. So those are equivalent expressions, and you can simplify it because you can combine like terms. 6b and 3b are like terms. Now, to write this as the area as a product, your common factor is going to be your b. So what you're going to do is you're going to factor out that b. And what are you left with is 6 plus 3. Now we're going to take a look at this one. It is not on your worksheet, but I would like you to go ahead and draw it, possibly if there's room on the front of your worksheet. Do not draw it on the Let's Distribute without the model space, the 2 blank spaces at the bottom of the back, because we're going to need those. So let's take a look at this one. We have the area of the rectangle on the left, which is red, and then we have the area of the rectangle on the right, which is blue. So to write these as the area as a sum, we're going to have to do x times 3x. Then we're going to have to take x and multiply it by 4. And we're going to add those two. Now, to simplify this, we have 3 times a 1 that is here. So that's 3. But whenever we take x and we multiply it by x, it's going to be x squared. Whenever we have 4 and we multiply it by 1x, it becomes 4x. So to reiterate, the one on the left becomes x squared because you are multiplying an x times an x, so it becomes x squared. Whereas in the second term, you just have an 1x. So that's why it becomes 4x. If you were to write this then as a product, you would factor out your x and you would be left with on the inside 3x plus 4. And those are equivalent expressions. Now we're going to go ahead and distribute without a model, so there's no drawing. It's the same idea, is that now 3 is your common factor. So you are left with x plus 7. So 3, they both have either the same height or the same width. And what you're going to have to do is distribute or multiply the 3 by each term. So you're going to do 3 times x plus 3 times 7. Well, 3 times x simplified is 3x, and then 3 times 7 is 21. So your answer is 3x plus 21. We won't keep it as the first expression because that's just showing us how we got 3x plus 21. You have to remember to distribute it both to the first term and to the second term. You have to multiply that 3. Let's go ahead and take a look at the next one. Now we have integers. We are multiplying both terms by a -2. So we have -2 times c plus -2 times -4. -2 times c is -2c. And then we have a -2 times a -4, which is a +8, and we are adding those. So our answer is -2c plus 8. Looking at the last problem. In order and before we can combine like terms, we have to first distribute the 7, which means multiplying 7 by both terms. So 7 times 3h plus 7 times 2 plus 2h. Well, 7 times 3h is 21h. You multiply the 7 by the coefficient 3 and you keep your variable. 7 times 2 is 14 and you keep your 2h. Well, 2h plus 21h is 23h plus 14. So that is the same equivalent expression, just in simplest terms, because you have combined all of the like terms. Now go ahead and do these problems, the next 3 by yourself. Go ahead and hit pause on the video, and I'll be back with you in just a minute. Hit play again whenever you're ready to show you how they're done. So this is interesting. There is a negative on the outside. That is the same thing as a -1 being distributed. So if we have a -1 times 4s, so -1 times 4s is going to be a -4s, because a negative times a positive is a negative. Now, we have to distribute the -1 or the negative to the -3. So -1 times -3 is actually +3. So our answer is -4s plus 3. For the next one, we're going to do -3b times 5b. So we have -3 times 5, which is a -15, and then we have b times b, which is b squared. Now we have to multiply -3b times a +3. So -3 times +3 is -9, and then you keep the b. And plus 8b is the last term that you're going to put down. Now, can we combine any like terms? Yes. -9b and a +8b. -9 plus 8 is -b, or -1b, and then -15b squared is a term by itself that cannot be combined. So we're now going to solve the last one. We're going to take the 4 and multiply it by 8 and get 32. Then we're going to take 4 and multiply it by -3z and get -12z. -11 is a constant by itself. The two terms that can be combined are 32 and -11, so that will give you -12z plus 21, and that is the simplified expression.